Hello friends, welcome to Machine Learning, the future course. So let's start building our machine learning model for polynomial regression. So let's begin. So here we'll create both linear, simple linear as well as polynomial linear regression expression, and we'll compare both of them, the results of both of those expressions as well. So let's do that. So first of all, we'll create a linear regression model. And then fit our model. So fitting linear regression to data set. So we'll actually use scikit library. Underscore model. So from that, let's import linear regression as we already seen in our last part. From scalar.linear underscore model, let's import linear regression and let's create an object. Linear regression equals linear regression, and the next type, let's fit them. The method which we'll be using is fit linear underscore regression dot fit, and what will be the arguments? It will be x comma y. So this is our linear regression model where we have fitted the model into our data set, and in the next part let's do polynomial regression. To our data set. So let's do that. So for that, again from sklearn scikit library dot pre-processing class library, let's import polynomial features as a class. Polynomial features, let's create an object of this class. So you can see the arguments. You can just press command control I. It will take some time. Yes, it's coming. So here's the arguments for polynomial features. Degree is equals to 2, interaction only for. So degree is actually the degree of a expression or polynomial expression. So we actually initially keep it as 2, and then let's create xpoly as a new matrix of features, and we'll use fit and transform method. So fit and transform, which will transform our original matrix of features, which is x. So initially let's look at our x. So this contains the various levels. Our y, vector of dependent variables. So let's execute these expressions one by one. Yes, it's executed. And now what we have done over here is we have created a new matrix of features, which is xpoly, and we'll fit as well as transform the original matrix of features x, which will have an effect of this xpoly. So let's execute this and we'll see what exactly this xpoly contains. So yes, these instructions are executed, and let's see what that xpoly contains. So as you can see over here, the initial value of x is this one, the first column over here. The next one is the squares. So the x1 square is the square of the x1 column, which is over here, and this one, as we have already seen our last part, is b0 x0, wherein it will replace all the b0 x0 with columns of 1 where x0 is equals to 1. So that is the expression y is equals to b0 x0 plus b1 x1 plus b2 x1 square. So this is our polynomial. That's why we have converted our matrix of features x into a x underscore poly. So yes, we have done it. So in the next part, let's see how to fit this into a linear regression model now. So in this, so yes, we have transformed x into x poly, and now we'll fit the linear regression to our x poly. So for that, let's create a new object which is linear underscore, and we'll use linear regression, mistake, linear regression. So yes, that's done. And the next step, let's fit new object dot fit, and what will be the arguments over here, x underscore poly comma y. So we have created a linear regression model, fitted our linear regression model to the data set. We have transformed x into x poly, and then we have fitted our linear regression model to x poly. So let's execute this. And why have we done this? Because we already know that multiple or polynomial regression is a special case of multiple linear regression. So yes, executed. So yes, we have fitted successfully our linear regression to x poly. And now let's do a visualization of this entire exercise. For visualization, we already created a template over here in our simple linear. So just copy that template and just paste it over here, and we'll actually do a minor changes here and there in this template. So initially we'll visualize the linear regression results, and again let's copy it again for our polynomial regression. Let's make some changes over here. There is no x train, y train over here, it's just x and y. So it's x, this will be y, the color will remain as it is, which is red. Now we'll plot it. So plot is based on x, which will be over here, and this will be removed. It will be line underscore regression, which is the object which we have created over here, and we'll use the predict method dot predict. And what will be inside that, x, color will be blue. Title, if you want, you can just change the title over here. Linear regression. So you can use position level over here, level and salary, and that's it. So we can again, so let's execute this first. So yes, we have got a graph over here. So this is a linear regression graph over here, and as you can see, our points are not properly matching to our regression model. So these red dots are the actual dots of our data sets, and the blue line is the regressor line. And as you can see, most of the points are actually not on the line, only one consists on the line. Now let's look at the polynomial regression. So we'll also need to make some kind of changes over here. Let's do that. X, what will be, this will be y, use this method again here, but we'll slight changes over here. Let's do that. So the object name is _2.predict, and it will be poly_reg.fit transform x. Color will be blue. This will be x, and in just a second we'll copy this out. We'll paste it over here. This will be polynomial regression, and I think we are ready. Let me have a look once again. I think this is an x is there. Okay, so the object or the plot is ready. Let's print it out. Okay, some error. Okay, this colon is missing. Let's print it out again. And yes, so here we actually seen the polynomial regression model. So that's great. So here we can actually see that it's trying to match to the expected values, our regressor model. So that will change as and when your degree value will change. So let's change the degree value to 4. Let's execute these instructions. Yes, it's executed, and now let's execute this. And you can see the change over here. Once you change the degree, it's actually matching your expected values or the original values, and the regressor line is actually matching this actual dataset values. So that's it from this video series. So that's the part for polynomial regression. Thank you very much. In the next part we'll actually see much more detail in this. Thank you very much. Bye bye.